Alright, so this is part 2 of our video series on drawing ray diagrams. Today we're going to do concave mirrors, and those are also known as positive mirrors. And that's an A there. Alright, so first, with all of our ray diagrams, we want to draw our principal axis, and we also want to draw the location of our mirror. In this example, we're going to have a focal length of 2 units, and so the center of curvature will be at 4 units because the center of curvature is double the focal length. And I'm going to start with an object outside of the focal length. We're going to draw it 1.5 units tall. Okay, so first rule we're looking at is a ray parallel to the principal axis. Will reflect through the focal point. Like so. Then we can draw another ray. This time the rule is a ray through the focal point will reflect off parallel to the principal axis. And lastly, a ray to the center of the mirror will reflect off symmetrically, like so. So we can see where the intersection takes place, and we can see where our image is going to form. Right? So if our object height and location is here, our image is going to form right there. And geometrically we can measure our image distance, which will be 3.3 units away from the mirror, with a height of 1.1 units in the negative direction because it's downward. Alright, so let's redraw this following the same rules, but let's look at an object that's inside the center of curvature, but not quite to the focal point yet. Alright, so again, here's our mirror. Might want to draw a little plus sign here to remind us we've got a positive mirror. And there's our principal axis. I'm going to redraw the focal point at 2 and 4. And this time I'm going to draw the object right in between the focal point and the center of curvature. We'll stick with a height of 1.5 units. All right. So first ray, a ray parallel to the principal axis, goes through the focal point, and a ray through the focal point make sure you line up your ruler as carefully as you can. So a ray through the focal point will reflect off parallel to the principal axis. And we can see where the intersection is. If you would like to put in your third ray, it's not a bad idea. A ray to the center will reflect off symmetrically. There we go. And now we see where our image forms. Right here. So we're a bit magnified. If this is our object, this is our image, we can see the image is taller than the object. It is 1, 2, 3, 4, almost exactly 5.5 units away from the mirror. And it is 2 really close to 2.5, 2.6 units pointed downward in the negative direction. All right, so let's do one more example. This time we'll go inside the focal length. So we have our principal axis, we have our concave mirror, and for a third and final time, we're going to draw our focal point at 2 and our center of curvature at 4. So there's our focal point, there's our center of curvature. This time, though, we're going to draw our 1.5 unit object inside the focal length. All right. So a ray parallel will reflect through the focal point. And it's important to remember that when you're inside the focal point of a concave mirror, you want to backtrack your rays to see where the image forms, because it will form on the virtual side of the image. Sorry, on the virtual side of the mirror. Next, a ray from the center of curvature will reflect back on itself. And again, we can trace that ray on the virtual side. And a ray to the center of the mirror will still reflect off symmetrically. I should have read that angle measure to get this exact, but I think we have a pretty good estimate there. So this guy reflects off like so. We can backtrack our line. And we're pretty sure that, well, I'm pretty sure anyway, that our image will form right here. So we have our image, we have our object, and in this example, the image will form 2.7 units away from the mirror on the virtual side, and it will be just about 3.5 units tall. All right, so I think we have accomplished our mission here. That's all for now. Thanks for listening.